So this is a quick video about a Minty signature, shielded Minty signature in ZCash, and how we can do that with Frost. So Frost is not literally out yet. It's a document or research that was done by the ZCash Foundation in cooperation with the University of Minnesota, I think. And the paper is they announced it, but the implementation is underway. So in ZCash, currently, what you want to do Minty signature, you will have to do it with a transparent address. Transparent address are pretty much the same way, works pretty much the same way as Bitcoin addresses. So in particular, they will use the same scripting language and nearly the same implementation. So you can generate a transparent address and make it pay to script hash with a script that is Minty sig, and then it will work pretty much the same way as before. But for shielded addresses, this is an entirely different story, because shielded addresses are completely unrelated to this scripting language, and there's a completely different mechanism and implementation. So the challenge here is to do Minty sig for shielded addresses, for sampling shielded addresses. The one thing with shielded addresses, and related to the fact that ZCash uses ZK is that you cannot change anything in the implementation of the address without having to regenerate a new circuit, because the ZK proof is actually hard-coded in a sense that they're compiled for a particular statement that you want to express. So that statement expresses something that is related to a single signature address. So when we want to do a Minty sig address, we have to make them look like a single signature address, which is pros and cons. Right? Pro is that from a payer point of view, everything will work the same way. He doesn't have to know. He doesn't have to know that behind the cover you are actually using Minty signature. The cons is, of course, that the implementation and the mechanism is going to be more complex. So I have done already the setup. So this is my scrapbook where I put the commands, and we are going to run these commands. Right? So the first command is go to this directory. This first command is for generating the addresses, the Minty sig. So you will see that it produces a secret key. And that secret key is not going to be used for signing, but it's going to be used for producing the view address, the view key, sorry, and the payment address. That's because the protocol we have different paths in that is participate in ZCash for the payment address. First, you can see it here, where what, not here. So transaction concept 12, page 12. Do we pass it? Oh, it's here. So you see that you have several components, and normally this guy derives everything. But the only thing that actually participates in the authentication or the spending is this one, this ASK. The rest is for like view key and so on and so forth. Right? So we are going to create a secret key that produces all of this stuff, but we're going to plug in our Minty sig here. So that key actually that is sent out here is going to be the same for every participant, for the 3 participants. But it also generates a secret share. So we have share 1, share 2, share 3. That will be specific for each participant, each signer. And it also generates a public key package, which is this guy, right? So each signer should get the that key here, his share and a copy of the public keys. So now next step is to use the address that is produced here to receive some coins. So we're going to do that. We're going to take, but before we do that, we're going to set up the wallet. So let's delete the databases, right? And set up a new account. So set up here, and this account here should be the result of this. So I'm going to save this up here, right? And now I'm going to import with this address. Okay, so this one goes here, and we can sync. So to sync, I need a like node D. So let me start like node D. So I'm gonna start like node D. I'll be right back. Okay, so that's the node, and then I need to start also the like wallet D. Okay, that is good. Then going back here, we can sync. We can sync with this command, right? And we are gonna request some coin. So I'll take this guy and go to the testnet wallet. Faucet, sorry, testnet. ZCash faucet. Right, so tap this guy, and now we are checking the testnet explorer. So this is not the testnet guy. This is the testnet guy. So our transaction should be in node 61. So it's not mine yet, and we need to wait for at least 10 blocks in order to be able to spend it. So we come back when it's 75. Okay, it's been a few minutes, probably 15 minutes. So let's see if we have received a coin. So we sync again, and we do a get balance. Get balance. Alright, so we have one, and now we prepare the transaction to spend that. So we're gonna send it back to ourselves. So this is our address, and that should send us 0.1 ZEC. But still, since it's our own wallet, this is going to be keeping the same balance except for the transaction fee, which is 0.0001 TSEC. So let's go first prepare the transaction. Okay, that means that the coin matured enough, and now we are going to prepare the minty-sig. So this file should now be sent, the 20x.json should be sent to the offline computer, but we're going to do everything from this computer. Every statement that has this line means that we need to connect to a line node, statements do not have this line can be executed offline. All right, so first we prepare, we commit, the first guy commits to a nonce. Okay. Second guy commits to a nonce too. All right, so this actually could be done by two different computers. As long as you transfer this file from the first computer to second computer once you have committed to the nonce, because the file is updated with format this stuff with these commitments. Right? We have commitment 1 and commitment 2 now. Next step is so we did there. And we are pre-signing the transaction, which means that we are building everything except the signatures. So we are building the ZK proof, we're building the entire transaction, except for the spending signatures. All right. So one thing here that has to be done before I forget is that we have to put the secret key that we had in the first place up there. All right. So we have to update this line here with our new secret key. Alright, let's do this. Pre-sign. Okay. So now the transaction has bytes. Right, bytes is the binary payload, and it has but no signatures. Alright, so no signatures. You see that. The commitments that are there. We computed the ZCash. So this is the message that we have to sign. And that's the next step. So we take that file and we bring it to the first signer. The first signer signs and creates this file. This first part of the signature. Second signer does the same to produce the second part of the signature. And these two guys are sent back to the aggregator. So aggregator is anybody who's gonna do this file manipulation. It doesn't have to be any of these guys, but we need somebody to combine the signatures together. So once we have combined the signatures, we can create the raw transaction. Right, raw transaction is this output here, and finally we can send that transaction to the network. Right, so that's the transaction ID, and you can go to the Explorer and see that the transaction is out there. It's not mine yet, but it's valid. Okay, so in summary, the process is as follows: you create this multi-sig signature with a threshold and a number of signers. And then when you want to spend from that account, you ask each signer to first commit to a particular nonce. Right? Then you pre-sign the transaction. So you build the ZK proof and everything, binding signature, blah blah blah, everything except the actual spending signature. Then you ask each signer to prepare its share of the signature. So that's SIG1 and SIG2. Then finally you combine these signature parts to produce the final signed transaction, and then you can transmit that one. Okay, so that's it. This is an example of how to do multi-sig transaction with a cold wallet. So at no point did any of these secret keys. At no point these secret keys were put on the online computer. Right, so already you had a cold wallet, but now it's also a multi-sig cold wallet. Okay, so if you are interested in knowing more, please ask questions. Frost paper is published, so you can take a look. I won't publish this implementation because it has it's quite messy at this point, and I know that the ZCash Foundation is actually working on official implementation, so I think I can wait for that. Most of the work here was related to actually the serialization and exchange of messages to encapsulate the different steps. So I think the crypto part was already done inside, probably done inside this package called Red Jujube. All right. I hope it was interesting. And again, if you have questions, please let me know. If you also have suggestions about how to do this better, please also let me know. In any case, that's it for today, and I hope you have a great day. Thank you.